Thanks. Well, thanks for the invitation. As was mentioned, I am actually in Canada at the minute, but I'm here for the IWA Water Congress. But my real job is I'm a senior lecturer, as mentioned, at Cranfield University, which, if you've never heard of it, you're not alone. It's a very small university, but we're sort of sandwiched in between Milton Keynes and Bedford. I'm part of the water science group there, and we do an awful lot of research around all things water. There's a big focus on sort of engineering aspects of water treatment, wastewater treatment. But I'm a bit of an odd one in that I'm a social scientist. So a lot of my research there is in things related to sort of public perceptions of the water sector, which is interesting at the minute, and policy and regulation and how the sector is governed in general. So water recycling has been a focal point of mine for more than 10 years now. I've been kind of following with interest how the interest in water recycling has developed in this country over time. And it's become increasingly prevalent. So that's what I'm going to talk about today. Some of the public perceptions work that I've done around that. Right, so a picture often says 1,000 words. And this one, I think, these two, in fact, said quite a lot as far as the challenges that we are potentially facing. They made the rounds in 2022 when we had a very, very dry summer. I spoke to the media at a couple of points during that drought of 2022. And they kept asking, well, is this a sight we should get used to, this brownness? And I had to say, well, in fact, yes, we probably should, because these sorts of dry events are likely to become much more common. 2022 was a fairly serious version of it, but the fact is we are heading to more frequent events of that kind. And the idea that England is a green and pleasant land is being challenged somewhat, because brown and pleasant land doesn't sound quite as nice. So there are some pretty significant challenges that we're facing, but this, I thought, illustrated them quite visually at the time. So just to give you a bit more of a breakdown into the sort of scale of the water resource challenge that we're facing, our sort of most recent analysis by DEFRA and the Environment Agency predicts that we're facing a shortfall of 4,000 million liters per day by 2050. Now that is the shortfall. That's the gap between what we are likely to have and what we are likely to need. This was rather colorfully referred to by the ex-head of the Environment Agency, James Bevan, as the jaws of death. So he wasn't one to mince words about the scale of the challenge. So yes, it's a point which we don't want to reach, but that's currently, if we do nothing and don't change what we are currently doing, that is the scale of the shortfall that we are likely to face. Now, there are a few reasons for that shortfall, and the kind of and that table on the right there breaks down numerically what they have modeled as driving that shortfall. So it's a combination of things. We do have a drying overall. The trend is towards a drier climate with different sort of precipitation patterns. When precipitation does fall, it will tend to fall in more intense bursts. So we may paradoxically see more flooding as a result of that. But overall, the trend is to be drier. And so that reduces the amount of water that's available in the environment. And we currently rely pretty much entirely on surface and groundwater, rivers and groundwater, and reservoirs as our water. Now, there is also a recognition, and you can see in the second column there, that the environmental destination, what they've termed environmental destination, is numerically the biggest driver of that shortfall. The biggest reason we are predicted to have a shortfall is from this recognition of the need to reduce what we take from the environment in order to improve the environment. So obviously a sort of big indication of that is chalk streams, and I know that's a focal point for you guys. There are some chalk streams that are at significant risk from abstraction, from taking water. But it's not limited to chalk streams. There is a general recognition that we need to take less from rivers, from groundwater, not just to protect the champion ecosystems like chalk streams, but on the whole to protect our rivers and groundwater systems. So we have to take less, but our need isn't going down. Our demand is in fact rising. And that's what those next two columns are about: demand from household growth, so domestic growth, and business growth. And then on top of all that, we are likely to face more droughts. And so we need a certain redundancy in supplies to be more resilient to droughts. So all of this is driving that supply and demand further and further apart. And so that's why we end up with this massive gap between what we are likely to have and what we are likely to need. As I say, demand has not gone down. It is staying stubbornly high. And household demand is a big part of that. Public water supply accounts for about a little more than half of what we take from the environment. And household demand is about half of that, a little over half of that. So it's a big chunk of what we use. Not for lack of effort. It has remained relatively high and steady over the past couple of decades, really. You can see there it did drop a bit in the early 2010s, but then you may have heard of a global pandemic, and it sort of crept back up after that because of changes in patterns of usage. We were washing more, people were spending a lot more time in gardens. That also had a big impact on it as well. But yeah, just a lot of personal hygiene habits changed. So it started to creep back up again. And we haven't, post-COVID, we haven't seen it come back down. So, and as I said, that's not for lack of efforts on the parts of water companies or others to instill this message that water use should come down, that we should be more efficient. But on the whole, we haven't really seen that have much of an effect yet. And this graph kind of makes the same point. This is from one of the regional groups. In this case, it's Water Resources East, which is the east of England catchment. But you very much see the same kind of pattern in other regional groups as well. And the blue line at the top is basically baseline demand. So that's sort of the pattern that demand is likely to take up to 2050 in this particular region, if nothing is done. The orange line that kind of steps downwards, that's WAFU, water available for use, is what that stands for. So that's the supply, essentially. That's what we can produce. So you can see that kind of goes down in a step shape because there are certain inflection points where significant things happen that has to bring down the supply quite significantly, like quick reductions in abstractions, for instance. So don't worry about what the arrows are. It's just the overall pattern is it going down. And the gray line in the middle is what they feel that demand can achieve with good demand management practices. So through, the best we can do with fixing leakage and implementing behavior change and all of these kinds of things. That gray line, they figure, is about as far as we can get. So you can see that it does reduce, but it doesn't approach the shortfall, plugging the gap of the shortfall. It's still quite some distance from that orange line. So that's the difficulty we have. Demand management can only get us so far, but we can't not supply that water. Even under the law, we have to supply that water. Water companies are legally obliged to supply that water. So that water has to come from somewhere. And that's basically what we get to. We need, and as it says there on the graph, we need new supply options. This is largely repeating what I've just said, but yes, demand management is important. This is by no means an argument that we should forget all about demand management because it doesn't make a difference. We do need to try and bring our usage down. Behavior change campaigns are going to be important. Metering is going to be important. That's one of the main mechanisms that we know that can help bring demand down. Reducing leakage is obviously still important, and there's lots of plans in place to do that. arguments can be had about how quickly they are progressing, but they are in place. We do need to do demand management. It is absolutely vital that we do that, but it's not enough. Despite a lot of efforts, household demand in particular is proving very difficult to shift. Even where we do think we can save through demand management measures, that's based on some fairly big assumptions, which we don't know if those are accurate or not yet, because we don't really have long-term data on this. So we don't know exactly what we can achieve through, whether we're likely to achieve what we think we can through demand management. So we really do need alternative supplies. And as I say, one of the challenges in terms of this shortfall is this recognition that we need to take less. So the new supply can't be, we take more. We can't just take more from rivers and groundwater to plug this gap. That is not possible, and that would not lead to a good environment. That would lead to further problems. So we need new supplies that are not dependent on taking water from the environment as much as possible. That's where water recycling comes in. It is not by any means the only one. Desalination is also going to probably have to play a part in all this. But water recycling is one of the ones that can be delivered a little more quickly. That diagram on the right, that is from, I mentioned the previous one was Water Resources East. This is from Water Resources Southeast. So this is the one that is local to where you guys are. And you can see some of the plans that are in place there. There are a few water recycling schemes planned along the south coast. I don't think we have them in there, but yeah, there are desalination schemes planned as well, but further in the future. And the same is true in the southwest. The same is true in the east of England. We need all of these things. So I will talk a little bit more about the Hampshire one, which is I know the one that's local to you guys, but just again, sticking with the kind of national picture at the minute, the current proposals in the most recent round of water resource management plans. So there are desalination schemes, there are reservoirs, there are water recycling schemes, and there are transfers. And some of those are combined. There are some where the water recycling schemes are feeding a transfer. So there's a little bit of overlap there. Water recycling is very much not the only solution. There are a number of solutions that are being put in place, but I think the recognition is it has to be part of the picture. And I think one of the issues here is for a lot of these schemes, there's a very long lead time. So when you look at reservoirs, for instance, you know, the infamous Abingdon Reservoir in Oxfordshire has been in the works in various forms for 20 odd years. The Havant Reservoir, that one's going ahead. Obviously, that one's now, I think, under construction, but it takes quite a long time to build a reservoir and fill it. And similarly with desalination schemes, they're not always very quick solutions. Water recycling schemes are not necessarily quick, but they can be quicker because they rely on existing infrastructure, like the sewage treatment works that are already there. So what are we talking about? What do we actually mean by the term water recycling? Well, there's many possibilities. There's one particular type that I'm going to refer to, but the term water recycling encompasses quite a wide range of things. And it's where you take a source of wastewater, which could be from any number of streams, but municipal is, sort of municipal sewage, essentially. But there's also industrial wastewater or rainwater and grey water. These are all the kind of potential sources of wastewater that could go into water recycling. You pair that with a form of treatment technology. There's a lot of possibilities that can go into that, which would be an entirely different lecture. You can have different ways of supplying that. There's indirect mechanisms and direct mechanisms, which I'll talk a little bit more about. And then there's which application you use it for. So the one I'm most concerned with today is the top one, using it to augment public water supplies. But there is also interest in use for non-potable applications, which can be all kinds of things. In household terms, you're usually talking about toilet flushing or garden use. Non-potable is anything that is not drinking, basically. Non-potable is a bit more complicated from a regulatory perspective. Our regulations don't currently exactly allow for this, except in some small scale rainwater harvesting stuff. But there's interest in that as well. So as one of the ways of bringing down our demand. So and in dealing with all of this, the regulations tend to look at the applications and understand the risks associated with each of those applications. And then you look at what the quality of the source is, depending which source you're choosing to use. And in between those two things, you select some treatment options that ensure that the source that you're using can be treated to the appropriate standard for the application and for the regulations associated with that application. And that's what we call a fit for purpose approach. You can tailor the water in some ways to make sure it's fit for purpose. Now that matters more for some of the other applications, but when it comes to the one that we're most concerned with today, which is using municipal wastewater, treating it to a very high standard, and supplying it indirectly as a means to augment water sources for drinking water, the quality standards that need to be achieved at the end of it are fairly clear. They're drinking water standards. So yeah, just the terminology can get confusing because water recycling can get, because it encompasses all of these things. When people say water recycling, it often gets confused with rainwater harvesting. And these things can fall under that terminology. But normally when we talk about water recycling for potable purposes or drinking water purposes, it's on this bigger scale. You can do it for non-potable purposes. And in many parts of the world where they do use it for non-drinking purposes, it's often in that purple pipe form. So if you Google purple pipes, there are many cities and regions around the world that have these purple distribution systems for non-drinking water, and it's often recycled water. But yes, what we are most concerned with today is the supply for drinking water. And we do have direct and indirect configurations. I'll explain a little bit more about what that means in a little bit. But it's the purpose that's important. That determines how clean it needs to be, basically. So this is what we would refer to as an indirect configuration. This is where you can see it sort of goes in a circle. You have the city, it produces sewage, it goes to a sewage treatment plant. That's standard practice at the minute. For water recycling, you would generally tack on an extra treatment plant at the end of that sewage treatment works. So it could take what was coming out of the sewage treatment works, which is already sort of good for an environmental standard, and it cleans it up much further to a very high standard. And then it puts it back in the environment, either into a river or a reservoir, where it gets re-abstracted and then treated again through the drinking water treatment works, and then gets put back into supply. This is the indirect in that it's going back into the environment first. That's what the indirect part means, is the fact that it's going into that river or reservoir first before it goes back to the drinking water treatment plant. All of the schemes that we're currently looking at in this country are indirect. There are not any direct schemes proposed that I'm aware of. But yeah, this is the scheme that is where you guys are, the haven't scheme. So you can see around the bottom there, you have the Buds Farm. So that's the wastewater treatment works. They're planning to put a recycling plant near that. So what comes out of the Buds Farm sewage works will get treated to a very high, very, very high standard. So it gets treated to a very high standard, goes into the reservoir, gets taken back out of the reservoir, and goes to the Otterbourne drinking water treatment works, which is up at the top there. And from there, it would go back into supply. So that's the current proposal. As I say, the other configuration is a direct configuration. Now, as I say, none of these, this system is not proposed in the UK currently. None of the schemes that we're looking at the minute have this particular configuration. But the direct refers to just, you don't put it back in the environment first. This is essentially what that means. So it's the same configuration. You have the advanced water treatment plant, you have recycled water on the back of that, but you basically take it straight to the drinking water treatment plant instead of putting it back into a reservoir or a river. Now, that generally wouldn't be the whole supply. You couldn't close the cycle completely because you lose some water along the way. So you'd have to blend that with some other sources. And this is done in different parts of the world. Some parts of the world do have this kind of system in place, but normally it's blended with some existing water. So it's not entirely a source on its own usually. Right. So the next bit I'm going to talk about, that's kind of an overview of what water recycling is, and where it's we're looking at it in this country. I'm going to talk about the results of a project that I did with the Drinking Water Inspectorate back in 2022 as well. And it was a project that was looking at public perceptions. So I'm not going to go through this in detail, but these were the list of objectives that they gave us to try and to do this project. They were just really interested in how people felt about the idea of water recycling. This was the overall approach we did. So it had two kind of data collection parts. One was an online survey. We had about 1,600 responses to that. And then we did some interviews as well, some follow-up interviews. We did compare some of the results from the survey with some previous survey work that we'd done, just to get a sense of whether things were changing. It's not a perfect comparison, but just to kind of get a view, and then sort of compiled all that into some results and recommendations. There was a lot of detail in our survey. We threw a lot of spaghetti at the wall with this to try and see what we could get. So I'm not going to go through all of it in detail. I'm just going to give you some highlights. I'm just going to show you the number of elements that this survey had. All of the demographic variables, you know, where people live. We didn't do income and things like this, but we captured a number of demographics. What level of knowledge they felt they had, how satisfied they were, some different value metrics in relation to the environment, to what extent they trusted water companies. Then we split the sample into some different treatment groups, which I'll explain in a minute. Then we had two main dependent variables, which were to what extent people would support the idea of water recycling and to what extent they would be happy to drink recycled water. And then we asked a whole bunch of other stuff about perceptions related to recycled water, its legitimacy, its risk, its benefits, its yeah. As I said, there was a lot in this, which the report is available, so you're welcome to go and read the report in detail if you want. It's on DWI's website. But yeah, I'm definitely not going to go through the entirety of the detail here. But this sort of split in the survey sample that I talked about, basically, everybody in the survey, everybody who responded to the survey had this basic explanation of what water recycling was. And we tried to keep that brief and as sort of neutral as possible, just very basic. Then half the sample got a diagram, the same diagrams I showed you, in fact, that was the indirect scheme, and the other half got a diagram that was the direct scheme, because we wanted to see if there was a difference between those, essentially. And then we split them again, and we had some where that diagram was labeled in a very neutral way, and then some where that diagram was labeled in what was deliberately a very inflammatory way. I'm not going to actually say what that inflammatory label was, because I guarantee if I do, the main thing you will walk away from this talk is that inflammatory label. And actually, I don't want people to remember that inflammatory because I don't like it. But we were doing this specifically because we wanted to see if just the label would influence how people felt. So we did that with both groups. So then we ended up with these four combinations of sort of the treatments, and then a control group, which didn't get any of the diagram or any of the labeling. So on the whole, we got some surprisingly high levels of support. So these were the responses to the questions of, you know, would you support the idea of recycled water, or would you be happy to drink recycled water? And the order of the legend, I apologize, is somewhat confusing there, but basically nearly 80% of people agreed that they were happy with the idea, and another large proportion were happy to drink this. So this was higher than we had previously found. We did a similar survey in 2018. It was still high, but it was less than 70%. But now we're up to nearly 80%. So it did seem like there was quite a lot of support for the idea. People generally happy with the concept. But the treatment group bit was interesting, because what it showed was those two with the red arrows there. Those are the two that had the inflammatory label. The inflammatory label groups were significantly lower in their responses, so they showed less support and were less likely to drink recycled water. in a statistically significant way. So the bottom line there was that label made a significant difference. It was still relatively high, like even with that inflammatory labeling, the support was still kind of on the high side, but there was a significant difference there. So some key findings here. A lot of people said they knew nothing about it. A lot also were convinced that it happened already. So as I say, the support was higher than what we had found previously. It appeared to have gone up. That label had a much stronger influence than the scheme design. So actually, when we put the groups together and we looked at the difference between those who had the indirect diagram and those who had the direct diagram, there was no statistical difference between those two if we combined the labels. So it didn't appear that people had any different reaction to the direct scheme compared to the indirect scheme, but it was the label that made the difference. So we did some regressions in terms of what were some of the strongest predictors of people's responses. Again, there's a lot of statistical stuff in the report that you can go through if you want, the extent to which people express positive feelings towards it and their relative concern around what other people thought were some of the strongest predictors of responses. And yeah, so those in the neutral label group had more positive norms and had more positive emotional responses. So there's strong links there. I'll talk quickly about the follow-up interviews. We did 15 of them, and we tried to ensure that you can never do this perfectly with interviews. It often depends who you can get hold of, but we tried to make sure that they were reflective, at least, of the sample. And we just tried to use those interviews to kind of explore the context, why people felt the way they did, how the introduction of different bits of information might change their view. And some of the key findings we had from that was that we reminded them of the same diagrams that they had seen in the survey. And it was amazing to what extent people would look at the diagrams and go, oh, I get it now. I didn't quite understand it before, but now I get it. And seeing, and they felt better about it having just seen the diagram. So these visual explanations were definitely helpful. There was a lot of questioning and then reassurance about the safety of the technologies involved in the treatment, and the fact that there's regulatory oversight, that water would have to meet the same regulation standards as any other water. It did reinforce the idea that people are very concerned about what other people think. There was a lot of, oh yeah, I might support this, but I don't think anybody else in my community would support this. Like, you could see that in the interviews, that people were kind of referring to, the wider context and what they thought other people would view on this. And it was interesting how people, once they grasped that this was not the one solution, this is partly why I was emphasizing at the beginning that water recycling is not the one and only solution here. There are a whole range of potential solutions being proposed to deal with the challenges, and that seemed to make a big impact in the interviews as well. And there was a general expression of when they want broad and interconnected forms of engagement. So they wanted to see a lot of outreach around this and see joined up messaging, which is not always that easy to get at in the water sector. So elsewhere in the world, water recycling is widely used. Often it's indirect, but there are increasing numbers of places that are using direct configurations as well. One of the ones that is moving towards direct is San Diego. They've been moving along this pathway for quite a long time now. They first approved a demonstration project for an indirect scheme in 2007. And they had a whole history of using non-potable recycled water before that. But they went to this demonstration scheme for potable water recycling in 2007. And they invested massively in public outreach at the time. They wanted to make a really big effort to, bring the community with them. And you can see the results of that in that graph. Those who strongly opposed it dropped in that time frame, and those who strongly favored it or somewhat favored it grew significantly. This was over a sort of roughly 10-year time frame. It really changed people's view. And they were, I think, through a lot of the intense outreach that they did, the community really came along. And now so they have they have a very, very large indirect potable reuse scheme or water recycling scheme in place. And they're now looking to shift towards more direct configurations. So water recycling is becoming necessary. We have very few other options to deal with the shortfalls that we are likely to face in a way that does not have an impact on rivers and groundwater. Demand management alone can't do it. Our survey was very encouraging that it seemed like people are not inherently against the idea. There did seem to be a lot of support for the idea. People do ascribe a lot of importance to social norms. So the idea of what other people think seems to have a big influence. That terminology really matters. And this is why I'm no longer using the terminology, even when I do these talks about terminology. And it is really, just to reinforce that again, it is part of the solution. It's not the one and only solution. Public perceptions can shift over time. We do see that it can go both directions. There seems to be good support for the idea here, and we're hoping it stays that way. Even if public support decreases, it has been shown that a lot of engagement work can help increase support as well. As I say, the report for that project is on the Drinking Water Inspectorate website. So please do feel free to go check it out. But you can also contact me if you want any follow-up information as well. But yeah, I can leave it there.